In this video, we look at using multiple rules together. And so what I mean by that is using the product rule, quotient rule, and chain rule and or combinations of those together in order to take the derivative properly. This lesson is really about training your eyes to see which one of the rules comes first. So if we look at this first example, I can see that I have a function multiplied by another function, and so that tells me that this is a product rule first. So I'm going to take the derivative of the first function using the product rule, which says to do that. That's negative 42 x to the 5 plus 6x. And then that gets multiplied by the second function as is. And then plus. Now the product rule says to take the derivative of the second function. Well, remember that a square root is an exponent of 1/2. So in order to take the derivative of this term, I can see that I have a function inside of something to the 1/2. So therefore it's going to be a chain rule. So the chain rule says take the derivative of the outside. So the derivative of something to the 1/2 is 1/2 something to the negative 1/2. I plug the inside function untouched. I then multiply that by the derivative of the inside function, and then the product rule says to multiply the derivative of the second by the first function untouched. And obviously we would not simplify that. There's no point to it. Looking at the second one, in this one I can look at and see I have a function divide by another function. And so this is a quotient rule first. But when I take the derivative of the numerator, I can see that that will be 7x plus 2 to the power of 1/3. So that will be a chain rule needed for that derivative. And similarly, in the denominator, we have a function inside of another as well. So we need a chain rule there. So setting up to do my quotient rule, it says take the derivative of the numerator. The derivative of something to the 1/3 is 1/3 something, and then we subtract 1 from the exponent. So that'll be negative 2/3. We plug the inside function untouched, and then we multiply by the derivative of the inside. That gets multiplied by the denominator untouched. Take away. Now we take the derivative of the denominator. Something to the 14 will be 14 something to the power of 13. We plug the inside function untouched. We then multiply by the derivative of the inside function. And then that gets multiplied by the numerator untouched. And if you wanted to write that as the cube root using a radical, that is all right as well. And then all of that is over the denominator squared. So to square an exponent, remember we just multiply. So you could write this as that all squared, or if you wanted to apply the exponent of 2 to the inside exponent, which I'm going to do just to make it a little more concise, that's to the power of 28, and there's my derivative. Now looking at this next one, I can see that I have a function inside of the square root. So this is a function inside of a function. Well, this is a chain rule first, right? So just rewriting this so that it looks a little more friendly in order to do our chain rule. This is something to the 1/2. So the derivative of the outside function is something to the 1/2, which is 1/2 something, and then we subtract 1 from the exponent to get negative 1/2. That then gets multiplied by the derivative of the inside function. Well, if I look at the inside function and focus on it, it's a quotient. It's a polynomial divided by another polynomial. And so in order to take the derivative of the inside function here, I need a quotient rule. And so the quotient rule says, take the derivative of the numerator, multiplied by the denominator as is, take away the derivative of the denominator, multiplied by the numerator as is, and then all of that is over the denominator all squared.